All right, so we are now going to learn about congruent polygons. We're going to move towards congruent triangles, but before we do, I wanted to make sure we understood a few things about what it means for two things to be congruent. However, before I can do that, it's important to understand how to name a polygon with vertex notation. Vertex notation means I'm going to use the points on my polygon to name it. So over here, I have hexagon, and I have the points A, B, D, E, G, F. Now, the order the points are connected is important. That's how we name it. You start with any point, whichever one you want, and then you pick that point. So I'm going to do A. After that, you typically go to the right or in a clockwise manner. So A is then connected to B, which is then connected to D, which is connected to E, G, and F. So this is polygon ABDEGF. It's not something we're going to have to do a lot with, but it's important that we understand how to name it. So let's review what congruent means. Remember that congruent means to have the same shape as well as the same size. You guys are very used to hearing this word. It's something you've heard a lot, and now it's just something that we're going to talk a little bit more about. The symbol for congruent is an equal sign with a little squiggly. And then if two figures are congruent, so if two polygons are congruent, then all of their corresponding or matching parts are congruent. So basically, if I have two shapes that are congruent, I can tell you that the angles are the same, that the sides are the same. So take a look here. I have triangle ABC and triangle FED. Looking at this, I know I use the symbol for congruent, so I know that ABC and DEF are congruent. So if I wanted to talk about side AB, I know that it is congruent to side FE. If I want to talk about angle B, I know that angle B is congruent to angle E. The reason that having the notation written out like it is above is helpful is because I don't even need the pictures to know that. I know that side AB is congruent to side FE because AB and FE are touching. I know that side BC is congruent to DE not only from the picture, but because BC and ED are touching. And lastly, I know that AC is congruent to FD because that, and then if I looped around C to A and then D to F, they are in the same spot. So using vertex notation like this is very useful because you don't need a picture to tell you that things are congruent. So let's draw these triangles, making sure that we mark the corresponding parts. So I'm going to draw a triangle PET, and then we'll do triangle DOG. So looking at that, because PE and DO are next to each other, I know that PE and DO are congruent, so I add a tick mark. Then I have side ET, which is connected to OG, which means ET and OG are congruent. And lastly, we have T, which then connects back to P, and G, which goes back to D, which means PT and DG are congruent. And now angles are really easy. P is first, so that means this mark means that P and D are congruent to each other because they're first. E is congruent to E. Q is congruent to Q. Oh, not Q, I'm sorry. Oh, that's an O. Sorry, guys. That's an O. I need to work on my handwriting, as you all know. And then T is congruent to G because they are in the same spot. So I had 3 markings to make sure I realize that they are congruent as well. Okay, now just to end up real quick, if you have all corresponding parts are congruent, what can you tell me about the hexagon? So if, say, this was 5, this was 5, this was 6, this was 6, this was 2, 2, 2, 2, let's do 4, 4, and then let's do 4, and then 4 again. You could tell me that ABDEGF is congruent to X, Y, Z, V, U, W. So we could write that using B, D, E, G, F, A is congruent to, and then B matches with X, so I do X, D goes to Y, E goes to Z, V, U, W. Okay, so if two corresponding parts of two figures are congruent, then obviously the two figures are congruent. It's not anything groundbreaking. It's just an important thing to remember that if I know the corresponding parts are the same, then the two figures are obviously the same. Okay, so looking at these, we know that these two polygons are congruent because I told you they were. So now we want to say, well, what do I know about each of the pieces? So angle F. So I'm talking about that angle. I'm going to come over here and see in my other polygon what one is congruent to it. Well, the one that best matches it is U, angle U. So I'm going to say that angle F is congruent to angle U. Side XY. So we're talking about side XY right here. Well, looking at that, I look on my other polygon, the first one, and I'm like, well, looks like B and D are pretty close together, and they look like their B goes to X, D goes to Y. So I'm going to say side XY is congruent to side BD. So taking a look at these two triangles, ACB and DE. So remember ACB, that angle is going to be angle ACB. That's going to be congruent to, looking on the other side, it looks like it's going to be congruent to this. So it's going to be congruent to angle, whoa, can't draw things, angle EDF. Okay, because I know these triangles are congruent, we can say that those are the same. So now come over to side DE. So side DE, so this side is congruent to what side? Well, I look at my other triangle, and it looks like, oh, it's congruent to side AC. So then I write AC with my line segment on top because it stops and doesn't start. And then that's it. So this is congruent polygons.